Okay, today we're going to be talking about dividing 4-digit by 2-digit numbers. When I say 4-digit by 2-digit, what I mean is a 4-digit dividend inside the division box by a 2-digit divisor, which is outside the division box. You should have your notes in hopefully by now. Notes on 25, practice on 26, and we are going to get started on page 25 with this right here. So the very top, it says, to find the blank in the quotient, extend the dividend by adding blank. Okay, this is if we are going to have decimals in the quotient. And we are going to talk about this at a later date. We're not doing decimals in the quotient now. We're sticking with remainders for now. Okay, so let's go ahead and fill in the blank. To find the decimal, that's a D. In the quotient, extend the dividend by adding zeros. Move it over a little bit.
You write it in?
These are your notes.
So yes or no? Yes.
Decimals in the quotient go up at the top. So sometimes you might have a decimal already in the number that you're dividing. Sometimes you have to add the decimal. Again, we're going to get to this in more detail. We'll come back to this page when we get into dividing with decimals. Today we're going to focus on whole numbers. What you need to know is that the number inside the division house is called the dividend. So when I'm using that vocabulary, I want you to know what I'm talking about. The divisor's on the outside and the quotient is the answer on top.
So the quotient's of the worker.
The quotient is the worker?
Because technically, like, you know, a roof worker would be
Oh.
the roof.
Ah,
Then the divisor's the neighbor coming in from next door.
I like it.
And dividend is the guy that's inside.
Oh, is
I
the
like
guy
it.
that owns the house. Yeah.
Okay, so on the left side where it says partial quotients, we are going to save that for later, okay? Today we're going to just focus on the standard algorithm for dividing by 2-digit divisors. So we have a word problem that we're going to solve, and it says Molly has 8,345 coins to place in 43 plastic bags. It's a lot of coins to separate into 43 bags. So I'm going to circle my numbers. And I want to underline my question. How many coins will be in each bag? So each is a key word. And right now, I'm going to ignore round to the nearest hundredths because I'm not using decimals. So we're not going to be rounding today. When we do decimals later, we will. Okay? So let's look at the standard algorithm side. It's already got it set up for us, but we need to remember these steps right over here, the process steps. What does the D stand for? Divide.
Divide.
What does the M remind us to do? Multiply. Subtract.
Sister.
Bring down.
Bring down. Okay, and the C we're going to do later. That's compare.
Yeah, that's comparative. That's one of the most important parts.
You can compare. We used to do like remainder, R for remainder, C for compare. When we start including decimals, we're going to be comparing more. Okay, so we can go ahead. We can go ahead and write compare in here. We just won't be doing that because we're still using remainders at this point. Okay.
So that means they don't all of that. So that means after we do our remainders, we can use the pair and they're gonna buy a cat.
Okay. So what we're going to do is we are going to take 43 and divide it into 8,345. The same rules apply. I want to make sure I'm taking my divisor and I'm figuring out how many whole times it can go into each piece of my dividend. So I start one digit at a time. Okay, if I were to cover up all of this last part here and I'm looking at 8, can 43 divide into 8? No, so I put that placeholder up there. I'm actually going to use red for that. Okay, I scoot that over and now I'm looking at 83. Can 43 go into 83?
Yes.
How many? One time. How do you know, Abe?
Because but 3 plus 3 is 6, and 86 is 3.
Yes, exactly. So if I am doubling 43, if I were to put it in twice, 4 times 2 is 8, 3 times 2 is 6, so that'd be 86. It'd be too many. So it can only go in once, which means that 43 times 1 is what? 43. So I subtract that, and I'm left with 0 here and 4 here. So 40 is what I'm left with.
And then you break down 4.
I go over one more digit. Oh no. Oh no. Okay, I go over one more digit, so I'm gonna have to bring this 4 down, and that 40 turns into 404. I don't know why it went to the back all of a sudden.
Go up. You can see the red.
Just take the 3 away.
Okay, well, I'm just gonna pretend like it's covering it up. Okay, a quick and kind of easy way to do this. There's a couple different ways you can figure out how a double-digit number goes into a larger number. Okay, first, you can always multiply it by 5. 5 is the middle number. It kind of gives you an, okay, now I need to go up. It was too little, or I need to go down. But to save you time, especially in an instance like this, when it's 400, I cover up that last digit and this last digit. And I'm looking at now 4 into 40. How many times could 4 go into 40? 10. But can I put 2 digits up here in my quotient? No, never ever can I put a 10-digit number above 1 digit in my quotient. So then I would try 9. 9 is the largest 1-digit number that I could put up here in a quotient place, right? So let's try 43 times 9 and see if it gives us a number close to 404. Y'all check me and make sure I did it right.
Yeah, you did it right.
Okay, so we have 387. So that means 43 goes into 404 9 times, which is 387. That's my multiplication. Now I have to do what? Subtract. Okay, I can't take 7 away from 4 right here, so I have to come over and borrow. Oops, but I don't have anything to borrow from. So I have to go over one more time and borrow from the 4, which leaves me with 3. This now becomes 10. So now I can actually borrow from the 10, right? Because I'm trying to subtract this right here. So I'm going to borrow from the 10, leaves me with 9, and the 4 becomes 14. Is everybody with me so far on borrowing, regrouping?
I'm already done.
Okay, 14 minus 7 is 7. 9 minus 8 is 1. Bring down that last digit. 17 turns into 175.
4 times.
Now, if I use that trick again, okay, 4, just looking at the beginning of each number, covering up that last digit, 4 goes into 17 how many times? 4 times. Which means that 43 might go into 175 4 times. So we're going to try it.
I wrote down 4 and came up. I think you're right.
So 43 times 4, 12, 172. Does that work?
Yes.
Yes. So I'm going to put 4 at the top and subtract 172. So it would be remainder 3. But remember the question that I'm solving. It says Molly has 8,345 coins to place into 43 bags. How many coins will be in each bag? What's my answer?
194 with a remainder of 3.
194 coins in each bag, but I would have 3 left over that don't get put in a bag, or they just get, there's only 3 in a bag by themselves. Okay, you'd have to have a whole nother bag just for those 3.
Those 3 you just spit them in. They can just put it in.
Or you could just put all 8,345 coins.
Let's look next at our practice over here.
teleportation square.
Okay, on this one, it says there are 3,720 students that travel by bus to an elementary school. Each bus holds 60 students. How many buses are needed to transport all of the students?
All is a keyword.
All. What else is a keyword? Each, big one. Each can sometimes mean multiply and it can sometimes mean divide. So it's a tricky keyword. I personally always struggled with trying to figure out am I multiplying or dividing. So here's what I started trying to look for to figure out, okay, am I multiplying or dividing? I looked to see what numbers I know. There are 3,720 students total. This is like a total number. Does it tell me it's total? No, but it tells me that that's how many students are traveling by bus. And it tells me that each bus holds 60 students, and it wants to know how many buses are needed. So I know the total amount of students, and I know that I'm trying to separate those students on buses, right? And I have to separate them 60 students at a time. So you 60 go here, you 60 go here, you 60 go here. So what am I doing as I'm taking 60 out of that total group and putting them on a bus? I'm dividing. So I'm going to do 3,720 divided by 60. Okay. I think I'm just, how do I get rid of you? I want you gone. Well,
He's a
okay.
rug. You can't get rid of him.
All right. Yeah, I can't get rid of them.
It's a virus.
So if I'm looking at just the 3, can 60 go into 3? No, it cannot. So I'm going to put a 0 placeholder up here. Next part. 60 cannot go into 37, so I have to put another placeholder right here. Okay, so here's my placeholders. I have 2 of them. Now, can it go into 372? The question is how many times? So cover up that last digit. Okay, 37 and 6. 6 goes into 37 6 times. So let's try 60 times 6. What should that be?
360.
Right, because 6 times 6 is 36. Just tack that 0 on at the end. So 6 times. And I have 12 left over. I have 1 digit left that I'm working with here. Why can't I move that? Hang on. Oh, there we go.
It's magic.
Okay, there. I had to get rid of that square. I couldn't get it selected. Okay, so now I want to bring down my 0. 12 turns into 120. And looking at this, if I were to just cover up my zeros, I know that 6 goes into 12 how many times? 2. So 60 goes into 120 2 times, which is exactly 120. So my answer is
62.
B, 62.
What's 16 plus 60?
Okay, number 2. Says volunteers pack 5,600 donated toys in boxes. They put 50 toys in each box. How many boxes are packed with toys? Again, I'm given like the total number of toys that we've received. Okay, imagine like your church did a toy drive or something, and they've got 5,600 toys that they've got to sort into boxes. They're putting 50 toys in each box. So you're dividing. So I've got 5,600, 50. The question says, how many boxes are packed with toys? So I'm going to do 5,600 divided by 50. Now these are really friendly numbers. What makes them so friendly?
It's easy. It's like
What?
50.
What makes it easy? What about these numbers is easy?
They're both even.
They're both even.
And they both end with zeros.
They both end in zeros.
Know what the end is.
Yeah, yeah. So I could cover up that 0, this last 0, okay? But I always want to go 1 digit at a time. So I know 50 cannot go into 5, so I have to put a placeholder. I know 50 can go into 56, 1 whole time. 50 times 1 is 50. So I have 6 left over. Am I done?
No.
Nope. I got to drop that 0. How many times can 50 go into 60? Once. Have 10 left over, and I have one more 0 to drop down, and this would be 2. So my answer is going to be
112.
D, 112.
Let's go horses. We forgot sister. A sword in.
You're right, I didn't do the last part. I should finish my problem. There. I've explained what we're doing. I'll re-explain when we're done. Number 3, Ari uses 16 ounces of lemon juice to make 1 pitcher of lemonade. He has 336 ounces of lemon juice. So how many pitchers can he make?
336 divided by 16.
What am I circling first before I set anything else?
16, 336.
Underline how many
Each.
pictures of lemonade
And what am I boxing?
has? No. The has are ounces.
1 ounce.
Oh yeah, you circle 1.
1? How many? 1 pitcher.
1 pitcher. Because 16 ounces makes 1 pitcher. So we know that 16 ounces equals 1 pitcher. You can just kind of make that note to the side somewhere. So that means that I got to take my total number of ounces of lemon juice, which is 336, and I got to divide it by 16. So can 16 go into 3? Nope. But can 16 go into 33?
Yes.
How many times?
2.
Yes, 16 times 2 is 32. I have to subtract, and I have 1 left over. But then I must bring down that digit next to the 3 up at the top. So the 1 that I had left over now turns into 16.
I have a question. Instead of doing division, why can't you on this? Why can't you just do multiplication, like doing all the numbers that could be the answer?
I'll talk about that in a minute. Okay, 16 goes into 16 1 time, so my answer should be
21 remainder 0.
21 remainder 0. Paxton asked a really great question. He said, why can't I just multiply every single one of my answer choices by 16? You could. So I could do 22 times 16 and work that out. I could do 24 times 16 and work that out. I could do 21 times 16 and work that out. And I could do 20 times 16 and work that out to figure out which ones I can eliminate and which one worked. Which one's quicker? Dividing. You only do it 1 time. But there's nothing wrong with multiplying either. Okay, there's always more than one way to solve a math problem. That's just one more way. You can absolutely do that. It would work. Very good. Thank you for bringing that up. Okay, last one, number 4. There are 450 visitors at a library. Each library table seats 25 people. How many tables are needed to seat all?
How got cut off? How got cut off?
Yeah, it did. All of the visitors. Okay. So we have 450. We have tables that seat 25 people. So I'm going to take 450, which is all of my people, divide it by 25 to figure out how many tables we need. 25 cannot go into my very first digit 4, so a placeholder goes up there. But it can go into 45 how many times?
Once.
25 times 1 is 25. So I have 20 left over. Drop that 0. Now that 20 turns into 200. And if you think about money, think about quarters and dollars. How many quarters would make $2? 8. And it's exactly 200, so I have nothing left over. So my answer should be B. Now, if I want to double check and make sure that I did these right, which is what I'm going to have you guys do on papers that you've already finished, because when I tell you to double check them, make sure that you did them right after we've now done our notes together. I want you to make sure that your answers make sense. So you're going to take your answer that you got, you're going to multiply it by the divisor, 2-digit by 2-digit multiplication. And this should match what I started with. If it does, you know you got the right answer.
I don't have to add the remainder.
If you have a remainder, you have to be sure you add that back. Very good. Okay. Any questions on this one? Okay, we're doing one more set of notes today. If you will please turn well, actually, I don't think you need to turn the page. I think you should have the right side, page 27, open. So I'm going to pass out some notes and practice for you to glue in to page 27 and 28. Go ahead and update your table of contents while you're waiting for your pages to come around. All right, now we're going to be dividing with zeros in the quotient. So this is any time you have a divisor that goes into one of your pieces of your dividend 0 times, okay? What do we do when we have a 0 in the quotient? Now again, this is going to involve decimals. We're going to stop when we get to a certain point, and when we actually get to decimals, we're going to revisit this page and we're going to finish out the problem with a decimal number. For now, we're just going to pretend that we have a remainder, okay? Okay, so it says find the quotient and round to the hundredths. The rounding to the hundredths will be later when we have decimal numbers, okay? My problem is 7,456 divided by 31, okay? It's giving me the problem horizontally. Do y'all see that my problem is right here horizontally? So step 1 says to rewrite the problem. You have to set up the problem. You've got to be able to identify what is the dividend, what am I dividing, and then what is the divisor, what am I dividing by. You have to be able to set that up into a problem to solve. Then you can ask yourself, okay, how many 31s are there in 7? There are 0. Womp womp. But how many 31s are there in 74?
2.
There's 2. What is 2 31s?
62.
62. Mm-hmm.
You can't have 2 31s.
I have 31 and 31 together make 62.
Oh.
Does that make sense?
Yeah.
Okay. All right. So now I'm going to subtract because I've done my multiplication part. So I subtract and I'm left with 12. But I still have digits in the dividend that I need to bring down. So I bring the 5 down. 12 turns to 125. How many 31s go into 125? If we're not sure, this is where, very good. This is where that trick comes in, where you cover up part of it and you ask yourself, how many times can 3 go into 12?
4.
And it is 4. So let's try 31 times 4. And I get 124. Does that work? Yes, it does. So I subtract and I'm left with 1 and I drop the 6. Now 31 goes into 16 0 times. This is where most students mess up, is when there's a 0 in the quotient, because not you necessarily, but students typically forget to put that 0 up there and it messes them up. It messes up your number. Okay, so my answer here would be 240 remainder 16. A lot of times I'll see 24 remainder 16. But if you were to check your work, then you would know that 24 times 31 does not give you 7,456. So then you'd have to revisit your division and see what you did wrong. And you would probably catch then that you forgot your 0 in the quotient. Okay? So, oh, I messed up. Hang on. I put this in the wrong spot. That should be a 2. This was a 2 and this was a 4. Okay. We know that there are 0 31s and 16. So we put the 0 in the quotient. Now, if we were to keep going, because you can keep going, if you were to type this problem into a calculator, the calculator's not going to tell you that your answer is 240 remainder 16. It's going to give you a decimal number. That's going to be point something something something. Okay? So this is where we will continue later when we get into dividing with decimals, because there's a step that you do. For now, I'm okay with you saying, hey, my answer to this question is 240 remainder 16. Okay? So I would put remainder 16 up here for now. Now let's look at our practice problems.
Hey, now it's red. Now the square is red.
Mm-hmm. Henrietta has a length of fabric measuring 14.20 meters. Okay, we might not do any of these actually. Because these all have, nope, we're not gonna do any of them.
Can we just circle all the
Okay,
answers?
so what we're gonna do, what we're gonna do, we're gonna save this because we will come back to it. You do have to know how to do this with decimal points, okay? The main thing today is I want you to remember to put your 0 in the quotient if it goes in 0 times. Whether it's a placeholder 0 or an actual 0 that makes up the number, you have to remember to put it up in the quotient. Okay. Today we're going to check over the work that we've done the last couple days since we didn't get to do our notes beforehand. You just had to watch whatever videos I could find online. So we're going to get that practice out. It should be in your math section from yesterday, I'm pretty sure. So take that out, what you did yesterday. Just look in your math section and let's take out what you got.